In this video, we will take a look at other substitution ciphers. The main idea behind sending encrypted messages is so that third parties cannot read the contents of those messages. So, naturally, we want encryptions to be difficult to break by third parties. Let's say that Alice wants to send an encrypted plaintext message to Bob. To increase the security of her message, Alice can use a substitution cipher. For this type of cipher, Alice starts with a plain text message whose characters are elements of the set Blackboard A. Then she uses an invertible encoding function C to convert the plain text characters to numbers that are elements of the set ZMod27. Then Alice uses an invertible encryption function E to change and scramble the numbers resulting after the encoding function C. The numbers that result after the invertible encryption function E are also elements of ZMod27. Finally, Alice converts the scrambled numbers from ZMod27 back to plaintext characters using the inverse of the encoding function C. For example, suppose that Alice uses the encryption function E from ZMod27 to ZMod27, given by E of A equals 2 times A mod 27. Using the encoding function C, which we discussed in a previous video, the plaintext message Starlord becomes the numbers 19, 20, 1, 18, 12, 15, 18, and 4. Now, to encrypt these numbers, Alice passes each one through the encryption function E. E of 19 equals 2 times 19 mod 27, which is 38 mod 27, which equals 11. Continuing for each of the remaining characters, the phrase Starlord is now encrypted as 11, 13, 2, 9, 24, 3, 9, and 8. Finally, Alice converts these encrypted numbers back to plaintext with the decoding function C-inverse. Decoding each of these numbers yields the ciphertext KMBIXCIH, which is then sent to Bob. Now, in order to recover Alice's plaintext, Bob must undo the encryption. Bob takes the ciphertext characters he receives from Alice and passes them through the encoding function C to convert the ciphertext to numbers, again, elements of ZMod27. Next, Bob uses the decryption function E-inverse to unscramble the numbers, which are then converted into Alice's original plaintext message through the decoding function C-inverse. However, in order for this process to take place, Alice's encryption function E must be invertible, otherwise Bob cannot undo the encryption. We will discuss element inverses in ZMod N in a later video, so for now, a brief description will suffice. The encryption function used by Alice was E of A equals 2 times A mod 27. To undo this encryption function, Bob must find 2's multiplicative inverse in ZMod27. The multiplicative inverse of 2 is a number that is in ZMod27 that when multiplied by 2 and the result taken mod 27, the answer is 1. The number that Bob is looking for is 14, since 2 times 14 mod 27 equals 28 mod 27, which equals 1. So, if Bob defines the function f from ZMod27 to ZMod27 by f of a equals 14 times a mod 27, then the following two compositions, E compose f and f compose E, confirm that f is the inverse of the function E. So, with this function f, Bob can undo Alice's encryption. Bob received the ciphertext KMBIXCIH from Alice, which he converts to numbers by use of the encoding function C. By doing so, Bob receives the numbers 11, 13, 2, 9, 24, 3, 9, and 8. To unscramble these numbers, he applies the function e-inverse, the decryption function, to each character. For the first number, 11, Bob computes e-inverse of 11, which is 14 times 11 mod 28, which is 154 mod 28, which is 19. Applying the decryption function to the rest of the numbers in the sequence, Bob recovers the sequence of numbers 19, 20, 1, 18, 12, 15, 18, and 4. Finally, using the decoding function c-inverse, Bob recovers the original message Star-Lord. This shows that Alice and Bob have a working encryption scheme.